welcome back. Wishing you all the best for CSIR Net aspirant. Just keep believing in yourself. You will surely achieve each of your goals. And may God bless you with boundless success. Again, good luck for exam. Today, I will discuss the new topic, sequence of function. I have seen in my earlier video sequence of number, and today I will discuss sequence of function. This is actually extension of sequence of number. This I had seen. Sequence of number is defined f from natural number to x, where a1, a2, a3 be any number, and the sequence is look like f1, f2, f3, so on. If we consider x as a real number, then this sequence is a sequence of real number. And sequence of function actually extension of sequence of numbers. Here each term of the sequence be functions. The sequences look like fn from x to r, where f1, f2, f3, so on are function. And this sequence is defined for all x belongs to capital X, where x be any space. Here the function is look like each function is defined as f1 from I to r, f2 from I to r, f3 from I to r, so on. Okay? Picture of the sequence of function is such type where f1, f2, f3, so on be the different function. If the sequence of function is defined for all x belongs to x, consider the point x1 here, then the sequence is look like f1, x1, f2, x1, f3, x1, so on. And for all point x belongs to capital X, I will get different type of sequence of function. This is actually the idea of the sequence of function. And definition is look like let D be subset of real number, and for each n belongs to natural number, let fn be a mapping from D to R be a function. Thus, fn is a sequence of function on D to R. D is said to be domain of the sequence of function. In particular, D may be closed interval AB or closed open infinity, or a open interval AB or A infinity. Getting the idea clearly? Well, as for example, if we consider fnx equal to x over n for all n belongs to natural number, if you consider this sequence of function, then this would be just look like f1x equal to x, this is straight line, f2x would be x over 2, f3x would be x over 3, this is also straight line, and this value actually keep going on. This would be f50x would be x over 50, this is also straight line, and f60x would be x over 60. Just continue this, and notice here when the value will be increased, then all function be set line, this is true, but here these become less and less strict, and when the value will be more increased, then actually the function will be same to 0 function. That means the limit of the function would be fx equal to 0. Are you getting the idea? Well, and if you fix the value x equal to 1, then f1 1 would be 1, f2 1 would be half, f3 1 would be 1/3, so on. That means the sequence limit n tends to infinity, f1 n would be just similar to 0. Similarly, if we fixed x equal to 3, then at this point, this sequence of function also tends to 0. And all the point here, all sequence of function actually tends to 0. Here, for a fixed value of x, the point fnx converts to actually the 0 function fx equal to 0 for all x belongs to x. The sequence of the function, limit means here the interesting thing, just constant function, not point, because here all thing depends on function. This is the concept of sequence of function. Mathematically we can tell, suppose we have x belongs to the real number, then x over n tends to 0 as n tends to infinity. Is here the sequence of function x over n converges pointwise to the function fx equal to 0. And here the fx equal to 0 means the limit of the function. Are you getting the idea of the limit of the function in a sequence of function? Okay. And here notice, here the convergence is pointwise. I have used the pointwise because here the convergence depends on the point of the set. Definition of convergent sequence of function is fn be sequence of function who is defined from x to r and for all n greater than equal to 1, then the sequence fn converges pointwise to f, where f defined from x to r. If fnx converges to fx for all x belongs to x. In the concept, what is the pointwise convergence sequence? Well, actually, epsilon delta definition of pointwise convergence is fnx converges to fx for all x belongs to capital X, such that the definition is for all epsilon greater than 0, there exists capital N which depends on epsilon and the point x, such that absolute value of fnx minus f of x less than epsilon, where for all small n greater than capital N. And here capital N depends on epsilon and the point x. Are you getting the idea? Well, now if we want to apply the epsilon delta definition in the sequence of function fnx equal to x over n, which I have seen few minutes ago, this convergence pointwise to f equal to 0 function. Here fn converges to f. Then if we want to apply here epsilon delta definition, for this at first consider any arbitrary number a. Consider a belongs to any real number. Then fn a equal to a over n. Then by the epsilon delta definition, absolute value of fn a minus f of a equal to absolute value of a over n, and by epsilon delta definition, this value would be less than epsilon. Or we all of us know by epsilon delta definition, we have to find capital N such that small n greater than this n. And from this line, we can tell easily n greater than absolute value of a epsilon. If we choose epsilon equal to 1, then this value would be n greater than absolute value of a. As for example, if a equal to 10 and epsilon equal to 1, then capital N should be greater than equal to 11. Value of capital N would be at least 11. Similarly, if we consider a equal to 100 and epsilon equal to 1, then the value of capital N should be 101. Have you understood why here define the convergence as a point-wise conversion? Because here the capital N depends on epsilon and as well as the point A. So, sequence of function, this convergence is called point-wise convergence. Okay? Well, now I will see other different type of sequence of function. Here fn defined from closed interval 0, 1 to r such that fn x equal to x to the power n. What would be the limit of this function? Notice the graph of the function is look like here the domain closed interval 0, 1. When n equal to 1, then the function sequence of function would be x. Then n equal to 2, then x square. N equal to 3, then x cube. Then x to the power 4, so on. Notice the limit would be 1 when x equal to 1 and 0 otherwise. This is here the limit function fx. Are you getting the idea? Here fnx converges to point-wise this function fx, because here the convergence depends on the point. Here notice one interesting thing. Each fn be continuous on the closed interval 0, 1. But point-wise limit function f be discontinuous at the point 0. This is the example of sequence of function which converts to discontinuous function. Okay. Now if we consider gnx equal to x to the power 1 over n, where gn defined from closed interval 0, 1 to r, obviously this function gn converges to c, where gx equal to 0 when x equal to 0 and gx equal to 1 when x belongs to open 0 close to 1. Because we all of us know limit n tends to infinity, x to the power 1 over n always will be 1 when x greater than 0. So this value is 1. Are you getting the function? This is also example of sequence of function in which each term means g1, g2, g3, so on, all be continuous. But point-wise limit function be discontinuous function. Okay? Now I will see other example. fnx equal to x to the power 2n over 2n minus 1. The fn defined minus 1 from 1 to whole real line. And this sequence of function we can write fnx as x times x over 1 over 2n minus 1. And notice, at first consider this part. Here consider this is as a Snx. Snx equal to x to the power 1 over 2n minus 1. And this is actually the subsequence of the sequence x to the power 1 over n. Okay? First, consider the closed interval 0, 1. Here, Snx equal to x to the power 1 over 2n minus 1. Then, in the interval, Sn converges to A's, where A's would be, notice, when at the point x equal to 0, the value would be similar to 0, and at first consider the closed interval 0, 1. Here, Sn x equal to x to the power 1 over 2n minus 1. Then, Sn converges to A's, where A's would be when x equal to 0, notice, here the value would be 0, and in the interval open 0 closed 1, the value would be 1. And when I will consider the closed interval minus 1, 0. Here, since the sequence of function is x to the power 1 over 2n minus 1, here Hn converges to H, where Hx would be when x equal to 0, then the value would be 0, and in the interval minus 1 to open interval 0, the value would be minus 1. Are you getting? And since our given sequence is x times x to the power 1 over 2n minus 1, then Fn converges to Fx means apply at first this limiting value, then multiply with x. Then this would be actually x when x greater than equal to 0 and minus x when x less than 0. Are you getting? This is our original pointwise convergent function. That means Fnx converges to Fx, and notice this Fx is nothing but only Fx is actually the mod x. Are you getting? Well, interesting thing, notice each term of the sequence be differentiable, but pointwise limit, since this is the mod x, we all of us know mod x not differentiable at the point x equal to 0. So I have got one sequence of function whose each term be differentiable, but pointwise limit function does not differentiable. Are you getting? It's a new type of sequence of function fnx equal to x to the power n times 1 minus x. Here notice the function is defined from closed interval 0, 1 to r. Now I will see what is the fx, what is the limit of this function. Here fn0 equal to fn1 equal to 0 obviously. And here x lies between from 0 to 1. So obviously 1 minus x lies between 0 to 1. Therefore, the picture would be look like such type, and absolute value of fnx equal to absolute value of x to the power n times 1 minus x is the value, absolute value of x to the power n times 1 minus x obviously would be less than x to the power n. And since I have seen few minutes ago, this value in the closed interval 0, 1 tends to 0 as n tends to infinity. So limit n tends to infinity fnx equal to actual 0, and this is the fx function. Are you getting? Well, let's see other sequence. Here fnx equal to 1 over n plus x, where n greater than equal to 1. Sequence defined on a domain close 0 open infinity. Here notice the sequence of function is look like when n equal to 1, then f1x equal to 1 over 1 plus x. When n equal to 2, then f2x equal to 1 over 2 plus x. And when n equal to 3, then f3x equal to 1 over 3 plus x, so on. Okay? That means this sequence of function here look like this is f1, this is f2, this is f3. And notice if we consider f1x equal to 1 over 1 plus x, then at the point 0 the value would be 1, and at the point 1 the value would be 1 over 2. Notice the picture again. And similar to the sequence of function fnx equal to x over n, when the value will be increased, then this function actually tends to the function fx equal to 0. Therefore, n tends to infinity fnx equal to actually limit n tends to infinity 1 over n plus x, and this is actually similar to 0. Are you getting the idea? Well, Now I will see another interesting sequence of function. Here the sequence of function fnx equal to 1 over n times x square plus nx, and this sequence of function is defined for all x belongs to R. At first, see how would be the picture, because here the f1x would be x square plus x, f2x would be x square plus 2x over 1 over 2, f3x would be 1 over 3 times x square plus 3x, so on. Here the picture would be, since f1x equal to x square plus x, f2x equal to half times x square plus 2x, f3x equal to 1/3 times x square plus 3x, so on. So the picture would be, notice this is the line x and this is the f1, f2, f3, here would be f4, such type, and here the limit of the function would be, the limit n tends to infinity 1 over n times x square plus nx equal to limit n tends to infinity x square plus n over nx over n, and obviously if we put the limit, then this would be x. That means here the fx would be x. That means this sequence converges to constant function x. Are you getting the idea? And here all x belongs to real number. Okay? Well, I will stop here. In my next video, I will discuss this topic elaborately. See you soon. Stay safe, stay positive always, and good luck for exam. Thank you so much.